Okay, so we're going to have a short panel and then some Q&A from the audience. So please, if you can stay, we will promise to wrap up at 11 o'clock promptly. So some great thoughts here from the panelists. I'm not sure it's worth spending a lot of time on the supply side. I think it feels like the consensus is that wind is it in Northern Ireland. There may be other things that may come along, solar, perhaps when 10 years from now when the costs will continue to come down. And if there are audience questions on that topic, we can always take those afterwards. But in terms of topics that the panel could address, perhaps we can just start with demand side management. We've talked about that a lot. Maybe we can get into a few specific applications. I'd be interested in the panel's thoughts on, particularly on demand response. We've seen a fairly significant demand response market develop in the US. A lot of that's supported by a well thought out regulatory and policy regime. We've had some comments from the panel on the fact that probably from a residential consumer perspective that may not be very practical, but from a commercial or industrial point of view, do we think that's an attractive opportunity in Northern Ireland? How do you think companies or entrepreneurs should be going about tapping into that market to encourage businesses and effectively pay businesses to shift their load from peak times to off-peak times? Tom, do you want to start?
I'll have a go anyway. Since I've been in this industry, which is now since the early 90s, demand side has always been mentioned, always been talked about, always been discussed as the sort of great boon to save power generators and customers extra costs. The difficulty about it is that I think Tomas touched upon this, is a lot of businesses want to do their core business. They're not kind of interested in the energy markets to a large extent. A lot of the large industrial users, energy costs are quite a small portion of overall cost, believe it or not. I'm talking 2–3% for even some of the large energy users. Therefore, to get them to change their behaviour is difficult. Over the years, there's been a number of schemes. I think, I'll have to go to the Republic of Ireland. I think it was one that's just finished. There's been a winter demand reduction incentive in the ROI for a number of years, which has worked well. It's been phased out now to reduce costs. In the ROI, we're putting in demand side units. During the sort of the good times, when the economy was good, customers didn't look at this stuff at all. Now costs are tight. There's a great focus on it. In fact, some of the customers we're talking to on it, believe it or not, are hospitals who have got a great capability for demand side management, believe it or not. And years ago they wouldn't have entered here. So it's in its infancy. It's going to be a certain number of customers who are attracted to it. To get it down to smaller customers, let's say corner shops or offices, it's going to be difficult. It's going to take a lot of technology, and it's going to take a service provider who takes all that away from them and effectively delivers a cost. And the model, for example, we're doing our demand side unit is effectively, we'll take everything away from you, and all you'll get at the end of the month is a payment. Nothing else. We'll decide and make most of the decisions for you.
Thanks, Tom. Other thoughts? Joe?
Yeah, I would say that whatever devices people want to use for demand side management need to have built in some sort of a proxy. You could envisage that in the longer term that price would be the proxy on the market for demand side management. So, I would envisage that I would have a device at home which would be monitoring the price of electricity on a wholesale or on a residential market, or even in a European context. And if the price went beyond a certain level, I switched off certain things. Now, the proxy could be price. It could be the amount of renewable energy. Is the wind blowing? I'm happy to run my washing machine, for example, if the wind is blowing. So one of the things I'd be saying is that whatever devices people, and it is going to require some devices with communications technology, whatever it's going to be, should include some sort of a proxy. And not just some settings, but should be communicating with the system to make decisions on the basis of whatever that is. And I think price will be the ultimate proxy.
Could I just mention one other, just on the price? Northern Ireland, I don't know if people know this, has got one of the largest, in domestic markets, got one of the largest penetration of prepayment meters. There's like something like 250, 300,000 customers in Northern Ireland have got prepayment meters now. it was put in around the debt management, was basically to stop disconnections. What they found when those results were studied, it also led to demand reduction. So it led to, I think it's like 6 or 7% average demand reduction for those customers. Now, it has no price signal. All it is saying is people like a top-up card. So people are recognising every time they put part. That alone has had an effect upon people's usage. The incremental change from that to a more complicated smart meter is not that great. And that's part of the conundrum of these smart meters. There seems to be even putting something reasonably simple into customers' houses, it will reduce demand down. What all the other stuff does to it, it's still the sort of question out there.
Just just my thoughts on it. I think that demand side response is very much going to be supplier led, probably in the initial phases as well. But there is that issue about customers probably not understanding how switching off load mid-cycle in an industrial process, what it does for them. So tools that help the customers to look at their production costs and understand the impact of how variable energy prices on their overall production process are probably going to be interesting. As well, Tom's point is important. The benefits of smart meters need to be fully understood, and it needs to go hand in hand. I genuinely don't think the customer is going to make that decision about when to switch on and off by looking at wholesale prices. What they'll probably do is wait for devices to come around and have an app on their iPad that says within certain parameters, if I set on a wash, don't leave it for more than 5 hours before you do the wash, but any time within that 5 hours time window, go ahead and do it. Somebody talked about earlier the Glendimplex solution for heating. That quantum heater is quite interesting. But for suppliers to roll it out, and I genuinely do feel this will be supplier-led, ultimately you're going to have to probably have smart meters in place for the suppliers to have the incentives to get the customers to engage with it. So there's almost a chicken and egg thing there. Maybe there's some advantage to be wait a little bit, particularly at the domestic side, before rolling it out, because you don't have the suite of appliances just yet to make it worthwhile. And once you have those suite of appliances, maybe then it's time to move to the smart meters. But let's not forget that at the industrial and commercial customer level, you already do have essentially all the incentives you need, with half-hourly metering are already there. So that's the first area of focus, and I think it'll probably be led by suppliers in the I&C sector, and then it'll trickle down ultimately to domestics.
David?
And certainly independent companies that might like to develop energy storage projects would have the demand side response category of their business a very proactive area of activity where it would be given priority really as to in the modelling of how we buy and sell energy and things. So we would be definitely that model citizen with regard to being responsible about putting the load on and off the system at the right times, because it forms part of the core business really of an energy storage venture.
Just a couple of thoughts. We've seen a number of very interesting, innovative demand response companies of different flavors. The US market is got a reasonable amount of liquidity where effectively companies bid effectively in an auction on a regular basis, effectively for negative consumption, and they have contracts with commercial customers who there's usually a fairly high degree of automation in their systems. We've also seen some innovative companies in the UK, one company called Kiwi Power based in London that works with hospitals, schools, data centers, warehouses, people with distribution centers. Effectively, they have a control system that works with either the backup generators that most of these larger companies or commercial facilities have anyway, and they have to run these generators for testing on a regular basis in any case. So it's a relatively easy sell to some of these big companies. BT, Sainsbury's, and Marks and Spencer's all participate today in demand response programs in the UK, and it seems to be it's an early market. The National Grid is working quite creatively with one of these companies, and we think it's a very interesting market potential because there's a clear price proposition in terms of what you get paid per megawatt offset, and you can set your business rules relatively easily. It's very automated, so we see that as a very interesting opportunity in the commercial and industrial sector. On the residential side, probably the one application we've seen the most compelling use is one where the consumer has almost no input into it, which is, back to Thomas's point, no one's going to sit around thinking, should I boil the kettle now or should I wait for half an hour till the price goes down? Clearly that's not going to happen. But given that most energy bills, household energy bills are sort of 40 to 60% are heating based, remote control thermostats are one of the most interesting areas for demand side management. And one company, there are a number of companies in this area, but a company in the West Coast in California called Nest Labs, built by the former Apple iPhone team, has developed a product that effectively learns from consumer behavior. As people use the product, you effectively can adjust your thermostat up and down based on different times of day, different weather. Effectively it learns over time, and it knows when you're in the house, not in the house, and learns your behavior and then adjusts the thermostat remotely or automatically. And they're seeing 20–25% savings just from that on heating bills. And then the next step is for them, they're introducing demand response programs with utilities. So, the customers they don't see anything, but they can get a rebate off their energy bill, literally by having the thermostat. So that's a very low sort of cost for the consumer in terms of infringing and asking them to consider whether or not they should be reducing the energy consumption for the washing machine or for the kettle. That's not something they should think about. But heating is a very, very straightforward. You can adjust heating in a building. If you could bring it down by 2 degrees a couple of hours in the morning and later on in the day when prices are lower, heat it up, and most people wouldn't notice that. So that applies not only to residential homes, but also clearly to office buildings, where there's lots of demand. Smart thermostats are driving demand response. Let's maybe could we switch to storage? And clearly, as part of the issue, we've got overcapacity on wind potentially. We've got to figure out how can we store this energy cheaply. David talked a little bit about compressed air, which is a very interesting technology. Any of the other panelists want to share some thoughts on what they're seeing out there in the market in terms of opportunities for storage applications, cost effective?
Well, there's certainly improvements in the technology of storage when you look at battery technology. Clearly, if you want big scale, you're going to have to look at pumped hydro, but pumped hydro is quite expensive. Batteries are starting to come down in price, and also to increase in their capacity to deliver. We've also seen for, I'd say, microgrids, a number of flywheel technologies that are being used, not necessarily for energy storage, but to assist the power system to remain stable with large penetrations of renewable variable sources. So we're seeing some flywheel technology, but typically at the megawatt to 2 megawatt level, and also batteries dissimilar, both lithium ion and some flow batteries.
Yes, so storage is interesting. Some technologies, some battery technologies are sort of advances in that, with higher molarity in the electrolytes at the distribution level. There's a company's developed an interesting vanadium redox battery that's worth looking at. It's at the distribution level. And while the guy who makes that tells me it's safe to put in my home, given some of the stories I've heard about the kind of acid that's inside it, I'd probably be a little bit skeptical. So in the home, it's going to be things, when it comes down, when the price comes down to a suitable point, which it's not at the moment, like lithium ion, maybe banks of lithium ion batteries in the home. Financing is an interesting point if you think about the distribution level and putting in storage on the grid to offset capex investment. You think about the financing models for these type of things. If it's done at a network support level, that's one thing, but take arbitrage price opportunities, getting financing around a revenue stream that's based off of price arbitrage opportunities is very difficult, and the rates of return that investors are going to look at for just buying at the low prices and selling back at the high prices are going to be very high. So even though the technology might come for a while, it's going to be a little bit for the business model, and the actual overall structure is there to support it, unless it's at the network level and to support a known constraint in the grid where the network operator can make a decision and put it on their RAB at a reasonably low cost of capital.
In fact, that's a good point, because if storage made sense, there'd already be a lot of storage connected to the network, but it doesn't make commercial sense at the moment. Only system sense.
Yeah, and it's the continued development of the technology and the monetization methods, which is where the focus of the DEC program is at the moment, for instance. I mean, there is the primary duty of the arbitrage, the buying and selling of power at certain times of day, but for the first time, intermittent sources through energy storage would be partially dispatchable, or at least it could provide standby power available for system support in the event of a major generation loss, for instance. That is a new departure, and there is money in a market sense available for that service, as indeed the whole of the spectrum of ancillary services to do with reactive power management, voltage support, and even with rotating masses type of technologies like compressed air or flywheels. Then you can substitute to some extent for the loss of inertia if you shut down regular power stations, and that's something which the electrochemical battery sector can't really do because there's no masses in motion. So there's quite a few thrusts of development here which are innovative, and you know, the trick, I suppose, is to try and pull it all together to sufficient scale that you can get some of these projects across the line. And I think that as far as influencing the policymakers are concerned and the people who decide upon the levels of the tariffs and the types of the tariffs, we as an industry have to do our best to go as far as we possibly can with what we've got today, and then make that final plea for support in a certain shape or form. And that's the evolutionary process that we've now embarked upon.
We've seen opportunities in so-called microgrids. In our case, it would be looking at, say, for example, a mine in a remote region. They tend to have either very weak grid connections or no grid connection at all, and they run on diesels. And they've got a number of things competing. One, the price of diesel is continuing to go up. Often head offices telling them that they must green their power supply and reduce their carbon footprint. So the guy in the plant has a bit of a dilemma. He's told all of these things. The price of diesel has gone up, but he's told, but make sure that the power supply stays on. So when you look at putting some renewable energy in parallel with the diesels, it becomes a miniature power system in a way, and it's the same problems that the power system faces. And the solution to these things is that you install some wind or PV, you run the diesels for the minimum amount of time, you put in a battery or a flywheel or something like that, and the key to the delivery of this is the control system. That puts the whole thing together, and that's where the real smarts is. Other people are making batteries and investing in batteries. Other people are making flywheels and investing in them. The key that puts it all together is the control system. And not many people are doing that. There are products from some of the OEMs, but frankly, a lot of their products are just their big control system, which is used to run systems, and their SCADA system, sort of shoehorned into for a smaller microgrid. There's only one or two solutions that are bespoke for this type of network with large penetration. And they say that they can reduce diesel costs, for example, by up to 30 or 40%. But without the right control system, it doesn't work.
Great, thank you, Joe. One last topic we'll spend 2 more minutes on, and then we'll open to questions. Energy efficiency, we had a few comments from the panel. Tom made some comments that customers wouldn't be willing to put money up for things that or for jam tomorrow. You know, I think what we've seen in the market is there's a lot of project finance funds available out there for energy retrofits, and with the new legislation in place for public buildings to be able to finance against guaranteed savings, it's a very interesting space at the moment that we certainly spend a lot of time in. The technologies there, whether it's lighting, building controls, and so forth, are I think relatively mature, so it's not necessarily a technical solution, but there are some very interesting energy services companies now coming into the market to address this area. I'd be interested to hear the panel's thoughts on what opportunities they see in Northern Ireland to sort of build energy services businesses around the built environment.
Maybe I'll start with that, and it's kind of on the concept of not looking at the market as a homogenous thing, so it's breaking the market up into the various segments. So the financing is probably key to this, and what rate of return customers are going to look for on it. So, when you're doing an investment model and you're thinking about it at one stage, you kind of sit there and you say 3-year payback, that's fabulous, but the reality of it is there are a lot of customers there who can't support a 3-year payback. So you're going to need to look maybe for external financing on that, even if the savings are guaranteed there. And then in assessing a customer for financing or thinking about what kind of measures you're going to finance, if you're going to put a fund to work there, the big concern is, what's that customer's ability to pay back? How confident can I be that customers are going to be there for the long term? That's the question you have to ask. And so so for financing to come into the market, it's about financing probably to come into the market in various tranches. The public sector is a really interesting one because the public sector is, probably, the single customer that investors will feel most comfortable about, and it heads off from there probably into the blue chip market and then on down into the various sectors. And you'll probably see a trickle down effect. I expect the public sector to be the first one tackled, then move on to sort of the larger, better known industrials and corporates to the extent that they're not financing it themselves off balance sheet, and then move down into other customers. But ultimately, when you're getting down to the smaller SMEs and that, you're absolutely going to have a funded, possibly even a publicly funded financing solution for it at that point in time. In terms of the measures, then the measures are here today and are pretty, the payback in a lot of these is pretty obvious. I think you're going to see further advancements in things like efficient lighting and building controls that are going to make a lot of these energy efficiency changes really obvious for customers as well. So it's a market that's going to set to grow, but starting the first place to look out for this probably in the public sector and services companies that go after the public sector with a good model targeted to the kind of energy efficiency opportunities in that sector and then filter out from there.
Just that, Northern Ireland at the moment has a funded scheme that Tomas talked about, in the NICEP scheme, which, for example, this year we'll spend about £600,000 with businesses to improve energy efficiency in the north. It's getting replaced by effectively an obligation, so the funding will dry up. An obligation will be put upon suppliers to, a bit like the UK and the way the south of Ireland's gone at the moment as well. Effectively what will happen is that we'll have a set of targets where we'll have to meet. If we don't meet those, we'll get fined if we don't reduce consumption. Effectively what that will mean is it has in the UK and will everywhere, effectively, if we can't meet those targets, that cost to get passed on to consumers, and that's the way it kind of works everywhere. The real problem you have is the market's kind of broke up into three. Blue chip companies, multinationals, they're all doing this stuff. This stuff's being done. The breadth, the expertise, the money that's been done. Public sector mandated to do it. It's still working through the public sector, both north and south in this Ireland, about what needs to be done. But that will get done. The real problem is the rest, and that's where the big opportunities are. And it really is coming down to companies just do not have the money to invest to do it. Now, what's the knock-on effect in that? There's an energy show in Dublin the last 2 days, which we had a stand at, and we took down 4 Northern Ireland companies, things like variable speed drives, lighting, pretty mature technologies, but save energy efficiency to get them under wing. They have a good take-up of it. But what they repeatedly find is when it comes down to putting the business case back to businesses, they cannot get the return. They cannot spare the capital, and business cannot do it to get it done. Simple as that.
It's always been a bit of a conundrum why it is that we have the sort of highest energy prices, electricity prices in sort of the competing regions, and yet the uptake of energy efficiency is the lowest of our competing regions. Really, because of our energy prices being high, we should have a higher uptake of energy efficiency, you would have thought. But certainly it is the first place that we should all be visiting, is how to reduce energy demand, because then the valuable renewable energy resources that we generate and store and distribute and control intelligently will actually match up better, will go further, it'll be an easier job. The matrix process did actually identify sustainable construction and buildings as a topic of future study. So I can certainly take on board the thoughts there today and feed that back as being sort of good start point for well, getting something off the ground with regard to a formal investigation and study of that?
With the intelligence being put onto the grid, it means that every potential customer is also potentially supplier, which means that any house that, for example, has a domestic boiler in it could put in a domestic CHP unit. And that means there are many tens of thousands of potential energy suppliers. Just as the internet suddenly hugely opened up computing and big data became available also, coming both ways, what is the panel thoughts on the same happening in the energy market?
The same thing has happened in Germany. In Germany, there's a northern problem and a southern problem. The southern problem is the amount of PV that is installed in residential homes. And this is having a huge impact on the local distribution network and ultimately on the transmission system. In the north, it's because they've got a large amount of onshore wind. And they've been looking at this for quite some time. And the solution that they have come, and actually it's had an impact on the load factor for gas turbines, and it's had an impact on the load factor for Swiss hydro. The solution is to build big links between the north and the south, and ultimately to build links east-west as well. So we would say that the solution is that we need to have big interconnections between different regions in order to alleviate some of these problems. That's what's happening in Germany as we speak.
Sorry, go ahead.
Just on that, in terms of the technology that will be used, if it's CHP and customers, burning gas at home to make heat and electricity as well, I'm just not sure that the technology is going to support that. If you just think about the O&M, Tom will tell you about his O&M costs for his power stations, probably keep him up at night. The concept of having a domestic fleet of CHP, what I've seen today is that I think the O&M is probably a little bit prohibitive on that, so I'm expecting maybe I do expect to see distributed generation, but it's probably going to be a little bit of time, and it's probably going to be at something maybe like having solar top-up as well. And one of the reasons I think that, in addition to the fact that I expect solar to come down, there's also a concept, and some people are talking about low voltage networks within the house as well. So the concept being you have your electricity meter where you get your AC supply in, and that still powers the white goods that are in your house. But then you have a bank of inverters, and behind those inverters sits a low voltage DC network, maybe with some solar top up that you have at home yourself, maybe with your battery that sits at home as well, and maybe because your flat screen TV, your iPad, and most of the goods that people want to have in their houses going forward will also run on a DC network. You're still going to have a large heating load in the house, undoubtedly. But I genuinely do think, unless there's a technology breakthrough, I think the O&M costs around domestic distributed solutions are going to make that difficult for a little bit of time.
I just beg to differ with you. I have had a CHP unit in 15 years,
okay, and
they are very cost effective. It's just, I'll not spend any more time on that, but I think that is a huge opportunity.
Okay.
Thank you. One other question?
My name is Frank Ferguson, the company is Narcon. We're all aware of the unpredictability of the weather and the effect on there are various systems that we have in producing our energies, our renewable energies. At the Sustainable Energy a couple of weeks ago, I posed a question: where is the funding available for things like CER, Certified Emissions Rebates, or VER, or for global warming and carbon trading? All that money is available, and we're inundated from the City of London. Somebody wants to build something in the middle of Africa. Why is it not available for the farmers, the poor farmers here, for growing economic and energy crops in this country?
CER, we've used CER as a company before, bought, traded them, and well, it's government. It's like it's Britain isn't going to solve it. It's government. I understand your point. The only thing I would say about carbon at the moment is almost worthless. Carbon's trading down at a tenth of what it was 2-3 years ago. It's a market that's unpredictable. The price of carbon has fallen because the economy in Europe's collapsed. Therefore, the amount of credits given out, there's too many of them. it'll take a big political, effectively what the European government's got to do with carbon is to say, I'm now going to take a lot of carbon credits away, make electricity more expensive, and therefore make carbon more expensive. Right? That's the carbon market. If for the reason I understand, and I didn't make up this policy, CERs are designed to help sort of developing economies who would otherwise do more polluting schemes to do schemes that would be environmentally responsible. They can then trade those on for the EU ETS scheme. I have no idea why it wasn't put down to farmers. However, there are schemes in the UK schemes, for example, the CHP was mentioned, the schemes for home generation for the amount of rocks for PV, for example, 4 rocks. It's very, very lucrative. It's very, very lucrative generation. It gets 4 times support, for example, the wind farm we get. So there are schemes out there for people to do, very small scale generation and for it to get very good payoffs. On your absolute point about why farmers, I take it, but it's a government issue. It's
Thanks, Tom. Well, let's take one last question if there is.
John Kinney from Cleanfields. I also was on the SEHP panel. There's just something I'm wondering about. There was a phrase used earlier on there about what makes system sense doesn't necessarily make commercial sense. I'm also thinking in terms of the opportunity for Northern Ireland, and we're looking for future economic development. Is there some way how we can use the whole collaborate through all the different stakeholders, whether that's customers, whether that's network owners, whether that's innovators or suppliers, to actually overcome that problem, the so-called valley of death that was mentioned as well? How do we capitalise on what makes sense but doesn't make commercial sense?
Well, I'm not sure that that sentence makes sense, because if it makes sense, it should make commercial sense. I mean,
sorry. It's the point. It makes system sense. It makes engineering sense.
I understand, but unfortunately, we're dealing in a world where things do need to be sort of financed at the appropriate rates. I mean, certainly. I'll let David comment on that. There are, as I mentioned earlier, there have been, and Thomas's slide showed it. The venture capital funding for a lot of this industry has dried up significantly because a lot of the risks associated with these technologies, because we're in a highly regulated industry where things just take a lot longer, and the more money is sitting invested in a company, that the more time goes by, that obviously the lower the ultimate returns. So time is against you when you're trying to get venture investment, and therefore you do need to invest in things that make sense from a commercial perspective. But trying to put together the systems side of things, clearly that's one of the reasons that you have this matrix report, is sort of to try to organize the different stakeholders in the economy and to align around and create some of the right incentives to work together.
Yeah, I mean, the big picture here, of course, is that we're in the midst of an effort to make a transformation to a low-carbon economy. That sort of process more or less comes to an end in 2050, when we've reduced our carbon emissions by 80% below what they are today. So that's a heck of a transformation we've got to make if we're actually going to achieve it. Now, in order for it all to move smoothly, and we've got to incrementally change things, when really you need revolutions rather than evolution. And on the carbon pricing, it's commonly held that you need 75 to 100 euros a tonne valuation before that would be a significant influence on energy efficiency uptake or deployment of renewables or whatever. So I think that if we do have these difficulties along the road where we want to do something, we see the benefits of doing it, but they're not realizable today, you have to wait for another 10 years for that to be viable, then that's absolutely the role of governments. And not just national governments, but the European framework, the international arena. These are the people that have to come in and stimulate this and guide us through it all. And I think governments know that that is their role to play as well.
Thank you, David. Look, I think that's a great. I was going to say last comment, but Joe wants to steal the last word here.
Well, it was my quote that it made system sense but not commercial sense, and that's all. As David rightly says, it's all about price, and the price of delivering storage. I would argue that if you, in a future where you have huge amounts of renewables on the system, you are going to need services that are not available today. You're going to have storage, you're going to have demand-side management, you're going to have all of these things, and you have to pay for them. So it's the price. It only makes system sense because I mean, TSOs love storage, but there's none out there because the price isn't right.
And look, I'm sure in 20 years, or in 37 years in 2050, when we look back, we'll think, why on earth did we go down this path? Why didn't the original wind developers think about, you know, an on-site storage capability? Well, we all know that they couldn't. They had wind technology, but we didn't have the storage technology. So it's, you know, the market is leading us down a path. I'm sure it's not always the optimal path, but I think from what I've heard today, there's clearly some very exciting opportunities for people to build businesses around it, just based on what I've heard about how limited activity there is around on the demand side today. I mean, it's you know, as David said, the highest electricity prices in the UK, and yet the lowest amount of activity around energy efficiency and demand side management. Huge opportunity there. And, you know, clearly around storage, you know, there are going to be some innovations. We don't necessarily have to come up with the technologies, but we can bring them in from the best of breed companies, and we can pilot them here. We can demonstrate and learn ahead of other countries how to adopt those technologies. And I think those are the opportunities that we have. So I'm very encouraged by, you know, what I've heard today, in the sense that there are clearly some opportunities here, particularly on the demand side. And I just want to thank each of the panelists for a terrific discussion, and for all of you for being willing to listen to us.
Thank you.